And so we begin. So here is the very first part of our building our parallel example, the in-class example that I mentioned I would do earlier. That is our medical office example, right? So here we are, step 1A, okay? So starting a new project. By the way, if you don't already have it over here in recent templates, the model view controller, I usually just come up here, type model, something like that, let it find it, there we are. ASP.NET Core web app using Model View Controller and C#. All right, next. So I'm going to call it Medical Office. Okay. And I'll maybe call it Medical Office Solution. Will be the name for the solution. We can put space in the solution name. That works perfectly fine. All right. Next. So I'm using .NET 7. We're going to change the authentication type just as we did in that little mask example to individual accounts because we're eventually going to use them anyway. We'll configure for HTTPS. We'll be looking at how you can work around that, change that later on. And that's it for now. We'll just click create. So I'm doing this, you notice in my work folder off the root of the C drive. I already talked about that. I prefer not to do it somewhere that the OneDrive is syncing. It just sometimes can avoid some issues. It just means I have to make sure I back up my work regularly myself. All right, so we're up and running. Okay, so we did a quick tour here the other day about what these different folders are: models, views, controllers. Okay, we had a look at the app settings, Jason. That's where our connection string goes, and so on and so forth. And of course, in Program CS, that's where we're going to be adding things like the support for the different DbContext and so on. We'll be doing quite a bit of work in there. But let me just come up and double click the project itself, and this gets our project file open. So I mentioned before, I'm much more comfortable working with this disabled. You can just delete it or change it to disabled, right? And we already have some packages in, but we're going to need SQLite. So that'll be the next thing I do is I come down here to the NuGet Package Manager, get the console up. I'm going to execute that line we were just talking about, the install package for Entity Framework Core SQLite. Sorry, I did that pretty quick, right? So this is the command I just put in, install package. It's right in my copy paste file. I should mention that you'll find up in Blackboard, each parts of this demo, I have this copy paste file, right, that I work from during the demo, and I give all this code to you so that you can use it to follow along, right? Students find that that's a very helpful tool in their toolbox of learning, right? So here's where we just got that from. By the way, here's a nice link to a reference on modeling. I encourage you to take time to look at that as well as you go through. Okay, so that gives us our SQLite here, right? So we're going to come back, we're going to get that all set up in a couple of minutes. So I'll just save changes for now. Okay, we're going to come back and revisit those in a minute, but let's actually start with our models. So if I come to models, right click, we're going to add two models for now, two classes, okay? One is my doctor, and one is my patient. Now we're going to be expanding our model as time goes on. But as a learning exercise, we'll do it a bit at a time, right? So coming back to doctor, I'm just going to put my properties in, okay? We already had the discussion that, I can come down here, I can go pro, tab, right? An int named ID, right? And that's my primary key, et cetera, okay? Our naming convention, I could go ID or doctor ID, but we've already had that discussion. So let me just copy and paste. So I have my int ID. I'm separating out first, middle, and last name. And I'm planning ahead, right, that I'm going to have that collection of the related child objects in this one-to-many relationship, collection of patient objects, okay, called patients. By the way, you don't have to do this, but it can avoid, like, if we don't initialize it to an empty collection, right, then it technically will be null, right? And since we're allowing nulls, that's not necessarily a good thing. It means we can't do like a dot add or something like that to this collection, right, with a null value, right? So this way we avoid that issue. It doesn't add much. I mean, a hash set, why are we using a hash set instead of a list? Well, it's the most lightweight sort of collection I can use here, right? So that's what I'm going to do. A hash set of patient objects that's just empty, okay? But it just means it's not null. So that's the reason why that's there. Okay, coming to patient, right? I've got a number of properties here we're going to add. So I'm going to do it all at once and get them in place. And we'll just quickly talk about them. So we have our primary key, ID, okay? I have a string for OHIP, one for first name, middle name, last name, right? Our date of birth. Notice I'm making it a nullable date time because, we might want to, in the real world, clients will complain very, very quickly. They sometimes want to make a start on entering, say, in the busy medical office, they want to start a new patient record. Well, they don't have all the details just yet, right? So do they want to be prevented from actually entering, this patient into the system just because they don't have their date of birth yet? No, they want to be able to start it and go back in and fill it in later. So that's one reason in the practical real world why sometimes you don't want to make everything absolutely required, right? So we're making this a nullable date time so we can carry on and enter the data even though we have to come back and fill that in later on, right? Expected yearly visits. Notice a byte is a very small number, right? So, that's going to do the job in this case, right? How many times are they going to visit in a year? It's just a guesstimate to give us an idea. Maybe a senior citizen with many, many health issues might be coming in almost once a month, right? Whereas, some people might not even show up even once a year. Okay, a good healthy person and so on and so forth, right? It's just to have some data to work with. Give me a break, okay? Now, as I said before, for the phone number, there's too many digits to store in something like a double, right? So I'm going to use a string instead, and we'll use different approaches to help us present that nicely on the screen and so on and so forth. Same with an email is just a string, okay? And here are those two key properties that complete the relationship, the one-to-many primary key, foreign key, etc., right? All right, so this is the most required, okay? We have to have the doctor object inside the patient class. That actually, with Entity Framework Core, is what establishes the one-to-many relationship. The other two are optional, right? When I say the other two, I mean I'm talking about this relationship here, this aspect here, this collection of patient objects in the doctor, right? Having the collection of the child objects in the parent, that's optional. It gives us the ability to include all the patients for the doctor when we go and select the doctor, just like you might with a join between the two tables in a view, right? Having this optional property in here, what it does is it gives us access directly to the integer foreign key value, right? By the naming convention, the fact that we have the doctor object, okay, of type doctor ID, it will be understood or assumed from this naming convention that this is the primary key. If we didn't have this, I know I said this before, but I'm going to say it again. If we didn't have this property in here, internally in the background, the system would create a property, right, to correspond to the foreign key value. And it would create a integer field in the database. I think it would probably have the name doctor underscore ID, right? So I'd rather have my own and just follow this naming convention. There we go. So that's part of the foreign key, right? This is what's actually stored in the database. But from our object relational mapping point of view, the doctor object allows us to include the doctor, and then we can access the entire set of properties of the doctor right here inside of the patient object itself, right? Okay, so that's the most basic implementation of these two classes. Now, we've already seen it once, so I'm going to take time now to actually include some of the actual annotations that will make our lives easier, right? For example, these are good names for properties: first name, middle name, last name. Notice we don't have spaces here. I'm using this, capitalize the first letter of each word, sort of case uh, in how I'm writing these. But we would not want labels, right, to appear on the actual user interface saying first name without a space between them, things like that. So that's one reason why we introduce some of our annotations. Okay, so let me put an annotation in here. Display name, first name, right? So that is used by this tool every time this is going to be displayed on the screen, whether it's a form input control or it's simply a display showing a read-only version of the first name, right? Whenever it displays it, it will use the string that I'm providing here. Well, maybe, okay, strings are nullable the way we're using it, so perhaps I do want to make this one required. Can't put in a patient record unless we actually have the first name, right? So I can put required, and then I can provide my own custom error message. You cannot leave the first name blank, okay? By the way, if I didn't give this, the system would generate its own message, but it's kind of in programmer speak, right? The property or the field, I can't remember which it does right now, first name cannot be null or blank or something like that. So this is a little bit more user friendly, providing my own error message than the system generated one. And you know what else? Perhaps my design calls for a limitation on the size of this piece of data, right? So I can set a string length, okay? Maybe 50 characters is what we decided. That should be more than enough, okay? First name cannot be more than 50 characters long is the corresponding message, right? And if possible, we've already discovered this will actually limit the number of characters we can type, for example, into a text box to that limit anyway, right? But sometimes you don't have support in the client browser to do that. So it's important to give this error message anyway, because in some circumstances, that might not be enforced in the client browser, right? That limitation of only being able to type 50 characters. So we want to give a proper error message as well. All right, so these are annotations that we're going to add to the first name. Now I'm going to do something similar for the middle name. Definitely we want a display name at the very least, right? And a string length makes sense here as well. Notice I'm not putting required, right? Because we're going to say, well, again, I don't want to be held up from being able to start creating a patient record just because I don't have their middle name. Maybe I only have the first and the last name. But it makes sense that, we do need to have those at a minimum. So I'm going to have similar annotations here on the last name as I did the first name, right? The display name, it is required. You cannot leave the last name blank, and it cannot be more than, we better allow a little bit more room here. Sometimes last names can be pretty long, okay? So we'll have up to 100 characters allowed for the last name. And that's it. Those are all the annotations that I need here in the doctor class, at least I believe so for now. We might come back and do a bit more work later on. So coming to patient, right? Uh, let's do something similar. Now the patient has first, middle, last name, so maybe I'll get those in place first, similar to what we've done already with the doctor. In fact, it's pretty much the exact same annotations here. Ooh, you might already be thinking, oh, maybe we should be using inheritance, have simply a person class with some of these properties, and both these could inherit from it. Well, we'll look at that later in the course. Don't want to introduce every complication possible at the very beginning. Well, how about this date of birth, right? Well, one of the things we can definitely do is specify the data type here, okay, being data type.date, right? That will give us an awful lot. We'll find in the user interface then we'll actually automatically often get those little pop-up calendar input controls, right? Because if we identify that it's a data type, well then the UI will often give us a little calendar we can use to set the date, which is a great advantage for us. Another thing that I definitely am in the habit of doing, again, this relates to the type of browser we might use, right? In order to properly bind the data and show it, okay, in some browsers, our date needs to be delivered in a specific format, okay? So here I'm saying that my display format for my date is going to use this format string, the 4-digit year dash 2-digit month dash 2-digit day. If you're ever not sure of the best format to use for a date, go with this one. It's actually sort of the SI International Unit standard format for dates, right? The reason why that works, okay, and why it's my preferred format for dates, right back to the early days, I'm talking early days of programming, back in Fortran on mainframe systems, right? If you use this format for a date, then even as a string, you can sort it alphabetically, and it comes out in the correct date order. Yeah, think about it. Year, month, day, right? Yeah, even just sorted as a string, it always works, right? So it's one of the best formats, my favorite format for dates anyway. But Google Chrome in particular, okay, is the culprit here. If you don't have it formatted this way, then when it goes to bind that little pop-up calendar to an existing value, it won't work, right? So that's something I'm in the habit of always doing, okay, is formatting the date in this way. Fortunately, we can do it, right? Now, let's start talking. Maybe I skipped over OHIP, but we're going to start to see that there are some really powerful, okay, annotations that we can use here, right? So if I come to the OHIP number, first of all, I want to make it required because you cannot, that's something that we can't even start the patient record without an OHIP number. That's fair enough because we can't bill, right? So we're going to make that required, okay? And, I might as well put a string length on it because OHIP numbers are exactly 10 characters long, right? So we'll put a string length of 10. I'm not going to worry about the error message here because even if the browser doesn't support limiting it to 10 characters, I'm going to put an even more powerful way of restricting the data entry. You've probably had some experience working with regex, okay, regular expressions. If not, I'll quickly talk about what a regular expression is. Okay, go Google it or Bing search it, whichever you prefer, to learn more about regular expressions. Actually, I'll have some links up in Blackboard about regexes as well, right? But the idea is that you actually have a funny-looking character string that can describe. In this case, I'm saying D for digit character, exactly 10, right? It can't be less, it can't be more, it can't be anything from a numeric digit, right? So as a regular expression, it's a fabulous way of imposing a certain pattern of characters. We can use them for all kinds of data input situations, right? And this way we're guaranteed that they type it exactly the way we want, okay? And it's a very powerful way to then control user input. The OHIP number must be exactly 10 numeric digits, and that's the message they'll get if they leave off a digit or type a letter instead of a number. Maybe they type the capital letter O instead of a zero. No problem. We will catch the error with this regular expression. Now, one of the beautiful things about all these annotations, anything that requires validation like this, if the browser can implement it right on the client side, then it'll happen right there before you even submit data back to the server. But if the client has, it's a really old version of some browser or it doesn't support JavaScript or they have that turned off because they're paranoid about allowing any scripts to run in their browser, doesn't matter. The data will always get checked again when it's submitted to the server, and then a response will go back to the user showing the error message, even if it couldn't be checked on the client side, right? So that's one example of an additional kind of validation besides required that we can put in place using our data annotations. Now, when we come down to expected yearly visits, it's another chance for us to do an additional one. Okay, I might as well put all three in here because there's nothing new about the first two. Okay, I'm going to have my display name, visits per year, because that EXP, VR visit, that's kind of okay for us, but visits per year, I think, is a little more human readable for the end user client, right? It's required. You cannot leave the number of expected visits per year blank. Okay. If you want to word that a different way, go ahead. Right. Here's the one, range. Okay. Now range can be a range of integers, a range of doubles, a range of dates. Okay. But we're saying ranges between 1 and 12. Okay. The number of expected visits per year must be between 1 and 12. Right. And that way we have that as a different type of validation that we can do. Okay. All right. We're on a roll. The phone number. This one gets very interesting as well because remember, this is a 10-digit number, but we want to control how they type it in. You've probably seen in many websites when you go to enter a phone number, it says just enter the digit without spaces, brackets, dashes. Just give me the digits of the phone number. Well, we're going to follow that approach ourselves. Okay. Again, I'll get all the annotations for this at once for the phone number. Okay, so it's required, right? We're going to use a regular expression. Again, because it's exactly 10 digits, we can reuse the same one we had for our OHIP number, right? So 10 digits, okay, a valid 10-digit phone number, no spaces, right? Look at this. Again, we're using data type. Well, we did that with date before. but there's actually a data type in the enumeration. Maybe I'll show you the enumeration for a second. If I just hit dot here, we have credit card, currency, custom, date time, duration, email address, etc., passwords, right? So in this case, it's a phone, okay? So we just find phone number here. There we go. All right. And that will, in many cases, give us nicely formatted phone numbers, and away we go. Okay. All right. Same thing with email address. Email address is required. A nice big string length because some emails can be very long. Okay. And data type, again, is an email address. So that gives us automatically, it'll make it a link you can click on with a mail to, and so on and so forth. Oh, I love these data annotations. They do so much of the work that in the old days we had to do in multiple locations with a lot of manual code. Okay. Now, for the foreign key, I want to point out a couple things here. I'm going to say it's required, right? It's a required integer anyway. You must select a primary care physician, right? Display, right? Doctor ID does not look very good on the actual website, right? We don't want to have it say doctor ID. We want to have it just say doctor. So that's why I'm giving you a display name of doctor. Now, in this case, the name of the class is fine. I could optionally put the same display name here, and in some cases, you'll find that it makes sense to actually here. I'm going to do it anyway. It's not needed because it's exactly the same as the name of the object, the doctor class, right? But just to point out, it doesn't hurt having the display name here. Some of our class names later on won't be as clean and simple as patient and doctor, right? They might, for example, with associative or intersection entities, as you've done in the past, right? If you can't think of a good applicable name for the purpose of the entity, our usual approach is we just concatenate together the names of the two parents that are on either side of this many to many, right? So if it was, say, well, I think we have one coming up, condition, right? A patient can have multiple conditions. Okay, have you ever had measles? Check. Mumps? Check. Things like that. And of course, there's no other name for it that I've come up with, so we'll often call that intersection or associative entity patient condition, right? Well, if we just glue those two class names together without a space between them, that doesn't make a very good uh, display on the user interface. Just an example of a class name that doesn't work very well on the UI. So sometimes we'll have both a display name for the object and for the integer as well. Okay. All right, so that gives us the final versions of our models. I shouldn't say final because we're going to be modifying them and changing them as time goes on. So the next thing we want to do is we want to actually add the DbContext. So let me come to my data folder. I'll right click, I'll add a class here. This class will be, I'm going to call it Medical Office Context. And we did something like this in our mask demo. So I'm going to inherit from DbContext, right? So I'll need to add the using for Entity Framework Core. Okay, sometimes it does it for me automatically. Yeah, I had to do it myself this time. All right, so what's going to go in here? That's from old stuff. No, I don't want to accept that. Okay, yeah, we do need the constructor because we use dependency injection in MVC here, right? So I'll get my constructor in place so I can insert my medical office, my options to my DbContext options, which will also carry the connection string along with it, right? Then I'm going to have my two DB sets, prop tab, DB set of doctor, which I will call doctors, right? And that's the convention I would not just encourage, insist that you follow, right? The object names themselves are singular, okay? Whereas the collections, and DB set is just a high-powered collection, okay, is in plural. No, we don't want visits. That's it. All right. So that's good. That gives our doctors and patients. But remember we talked the other day about the fact that we can override on model creating, right? Why would we do that? Well, this is that Fluent API. And that's talked about extensively in the online tutorial that I asked you to do, right? Right? Inside this Fluent API in the on model creating, we can use the model builder to do all kinds of good stuff for us, right? I'm going to do this first of all to deal with cascade delete. Okay, I'm going to prevent cascade delete from doctor to patient. So in other words, if you go to delete a doctor that has patients assigned, patients that this doctor is their primary care physician, then we want to say, no, you're not allowed to do that. Okay, you would have to reassign all those patients to a different doctor first before you remove that doctor from the system. Okay, and I can do that simply asking my model builder, okay, describing the relationship. Now, we did talk the other day that I can do this either from the parent or from the child point of view, right? This one is written from the parent point of view. So we start with the parent object. The doctor has many patient objects, okay, called patients. Okay, that's the property of the doctor. With one doctor, there's a foreign key of doctor ID. But here's the real point of it. All this is just to identify the relationship itself. And then we say on delete, delete behavior is restrict. In other words, we cannot let you cascade delete the doctor, and automatically delete all the patients, right? That would be the default behavior, and we just don't want to allow that to happen. Now, something else that we know, right? The patient index, the patient OHIP number must be unique. No two people can have the exact same OHIP number, right? So we can ask our model builder to do that for us by saying the entity patient has index on OHIP, that's the property of the patient, with dot is unique, right? And that creates a unique index on the OHIP number, guaranteeing that no two people will have the same OHIP number, which is an absolute business requirement in our case. Well, that's good for now. We'll be coming back to all these things, the model classes themselves, to the Fluent API, and making further changes as time goes on, right? But this is enough to get us started with. Now, remember app settings, that's where our connection string is. Now, it's your choice. If you want to have separate connection strings, right, for the login system, the security system, or identity, okay, the identity system, as it's called, from the actual production tables, that is a design decision that you would maybe make in consultation with your client. Why would you ever have separate databases for the logins from the actual production tables? Well, it typically would be done if you're going to share a common login among multiple applications. Then you might store those instead of having it in each database for each production, for each application, right? You might have a common login database that can be used for multiple, right? So that's one reason why you might do it. In my mask example, I just assume no, both of the production tables, all of our DbContext, basically the application DbContext and our medical office context, uh, you would use the same default connection. But maybe today I'll do it differently. I'll do it so that there's separate ones for each, right? So basically I can just comment out the one for SQL Server for now. I could delete it, okay? But in case I ever want to go back, it's handy maybe having it there. So instead I'm going to put in two separate connections here, connection strings. Again, getting this from my copy paste file. So default connection, okay, remember, I'm going to use that for the identity system, the security, medical office security. So that'll be one separate database from, in my case, medical office context, which will have actually all of my files. You know what? I wanted to show this, but in reality, in the future, I am going to want it all in one because I want to be able to work with them all through the same DbContext. So forget everything I just said. I'm just going to have the default connection and I'll just call it medical office. I'll have all the tables in the one database. It's not something we're going to get into this term anyway, this whole business of having a common login system for multiple applications. So I'm going to keep it simple so we don't have to switch to this later on. Okay, so default connection will just be the one. Sorry, I digressed. but I'm going to go back to the simple implementation. Okay, now we come to Program CS. It also simplifies things here because you see, all right, first of all, we're going to go and get, I'm just going to space this out a little bit, the one connection string called default connection, right? Okay, that gives us our connection string. So now for application DbContext, instead of all I have to do is change usequel server to dot use SQLite, right? And now the application DbContext will use my SQLite database, right? And I'm going to do exactly the same type of thing. In fact, I could copy this, paste it in, and say, no, this is my medical office context. It as well will use SQLite and the same connection string, right? So the way this has been laid out, if I wanted to have two separate connection strings, I would have two of these lines, with different names, right? So one might be security connection string, might be production connection string, right? If I was going to have two separate ones. But since I'm sticking with a single database for all the tables, this works just fine. I can just use the same connection string, right? My nice simple one for SQLite for both DbContext objects, application DbContext, and medical office context. Okay, so we have everything done now, so we're ready for our first migration, right? I can close this up if you want, just simplify things on the screen here, right? So what do we need? We need the package manager console. So I'm going to add migration. Okay, I'm not going to type. Specifying, by the way, if you don't specify the context like this with dash context, you'll actually get I shouldn't say an error, but I guess it is an error, comes up and says, oh, there's more than one context object found in your solution. You have to specify which one, right? So I'd have to come back and add this. So it wouldn't do any harm, but it would let me know, wait a second, you've got to clarify. I need to know which DbContext you want to add a migration for, right? So the -O is for output directory, right? I'm going to put it under data. I'm going to create a folder called MO for medical office migrations. And I'm even giving the name for the initial migration. I'm just going to call it initial. So now this will do a build. Maybe I should do my own build first of all, just see if I actually have any build errors. It would do it for me anyway, but this way I can deal with the errors first before I actually execute that command. All right, so we succeeded in building. Good. Okay, so coming back to Package Manager console, I'll just press enter. Build succeeded. Good thing. And there we go. So here is our first, migration. We're creating our table doctors, right? We create our table patients, okay? And notice that the primary key there is just the ID, but the foreign key, you're giving it a name, FK, patients, doctors, based on doctor ID. Okay, the column is doctor ID in the patient table. The primary table is doctors. The primary column is ID, on delete, referential action, restrict. So we're restricted from cascade delete, and away we go. Oh, look at that. Here's our unique constraint on the OHIP number. Okay, IX, of course, stands for secondary index, right? Patient's OHIP, okay, the patient, the column OHIP, unique is true, right? Why did it create this, okay, on the foreign key, the doctor ID? Well, that's the default behavior you typically want for performance because you're often doing joins in the database. A join between the two tables based on the foreign key, primary key relationship is always just much faster to execute a query like that if we have an index on the foreign key. That's good. That's perfect. That's everything we needed for now. Then I'll just call update database. All I have to do is specify the context is my medical office context. No red on the screen, so no errors. So it successfully was able to complete this migration and actually create the database. And I can see the database is here now. Because I have this tool, I can come in here to SQLite and have a look, right? I have to click the little plug button to add a connection. It looks and finds, oh, there's my medical office, DB. Look at this, I've got two tables, doctors and patients, plus my migrations history table, right? So I'll be able to attempt a migration and keep on adding new migrations, right? Noting each incremental change as I make changes to the model as time goes on. And the migrations history is used to see whether or not all of the migrations I have defined in code here, right, have actually been implemented or not. That's what the purpose of this migrations history table is. Okay, goes along with this snapshot here. All right. Okay. So now what we might want to do is we might want to create the tables for the identity system as well, right? So let's come back to our package manager console. Okay. One of the things that you should be aware of right now, this initial migration, this create identity schema, that was there, right, from the scaffolding we did when we first created the project. The problem is, and this is identified, I've got some notes on this right in my copy paste file. Okay, the identity system, application DbContext, that was scaffolded initially, it was created with SQL Server in mind, right? And it uses nvarchar max as a data type, right? That's like our blob in SQLite. Okay, it's not supported. There's no such thing as nvarchar max in SQLite. Okay, so we have to delete and recreate the migration here, right? So no big deal. It's similar to what we had talked about. Sometimes you have to do anyway. I'm just going to come to this migrations folder. I'm going to delete it. Don't worry, we'll recreate it again in a second. Okay, I'll do that here with this command in the package manager console, right? I'm going to add migration. The context this time is my application DB context. Output directory, we're going to recreate that same folder, data/migrations. Now I could call it the same name, but I'm just going to call it initial, right? And there we go. So we've recreated our migrations folder. It's just as initial, but you notice it has basically all the same code before. We're creating our ASP.NET roles, our users, etc. It's just that it's using all the correct SQLite data types and so on instead of the ones for SQL Server, right? Okay. And since we're here, we might as well get these tables in place. So I'll do an update database, okay, for the application DB context. All right, so it's creating all those tables. So if I come back to here and refresh, we have all the tables that are necessary for the security system right in our database, along with the doctors and patients table, right? Okay, okay. Well, that's good. We're going to stop recording at this point. This is long enough of a lesson. The last thing I'll do, though, I mentioned this before, these commands, you might end up running them more than once, okay? So what we're going to do is I'm going to, right here in the data folder, I'm going to right click, add that little new item, my text file, found under general or all, but text file. I'm going to put common commands that I type in repeatedly, right? And I can get them out of here if I just use that up arrow. I can go back to the history, right? So these were the ones for the security system. For the production database, for the production tables, I should say, in the database. There we go. So just I have them close and handy. I could put some notes explaining what they are, but I hopefully do know what they are, so I'm not going to take time to do that. So those are those ones that I've used in the past. Sometimes it's handy to have them right here in the project in case I need to run them again. Okay. All right. Well, we're going to stop the recording and start again for the next part of the lesson.